Hi, you've clicked on to today's tropical tidbit for Thursday, June 9th. So, based on people's feedback yesterday in my blog, I have decided to try to up the volume. It sounds like a lot of you have been having some issues with having to turn everything to full and then still barely hearing me. Linux has allowed me to amplify my input volume a little bit over 100%, so hopefully that helps. Let me know if this is louder or any better today, and hopefully this works. So looking at the tropics here in the Atlantic, fairly quiet overall down here, not a whole lot going on. There is still a remnant circulation from 94L that's kind of hard to see here before the daylight images show up. This is finally going to start lifting north over the next 2 to 3 days, still expected to get near Florida and hopefully bring some rainfall there. A lot of the activity is off to the east here in the Bahamas, but hopefully some of this gets into the Florida. I think some of it will. It's not going to be a lot, but some showers are likely to develop with the instability with this as it moves northward. And overall, this basin will be quiet for the next 10 to 15 days as we wait for the next round of the MJO to come through to bring us the possibility of another tropical disturbance perhaps before the month is over. And most of today, I'm going to be talking about Hurricane Adrian over here in the Eastern Pacific, and we're going to run through basically just a bunch of satellite imagery. So I want to show you a couple things. You can see that a little bit of a ragged eye is starting to pop out over here as the morning progresses. Notice how the cloud tops were actually pretty decent last night. We had some grays showing up, minus 80 Celsius cloud tops. Those have since faded, and we now have waning convection with only scattered areas of minus 70 Celsius or colder in the CDO. And you can see that the eastern side of this is a little bit broken. You can see that it's kind of eaten away. The eastern side of this eye wall is actually fairly weak in here. Here's the water vapor imagery. You can see Adrian right here moving northwest. Again, there's a weak area of clockwise rotation in here, a mid-level high pressure system, which is doing a couple of things. One, it's drawing dry mid-level air down into the northern side of Adrian's circulation from the north, and it's also creating upper convergence on this southeastern flank of the high, which is causing sinking air, which creates more dry air and also limits thunderstorm activity around the northern side of the system and limits the poleward outflow channel, which is nearly non-existent in here. Now, I've talked about these highs before last season, where if you have a hurricane coming northwest towards a mid to upper level high that is situated directly to the northwest of the system, it's never a great thing for the hurricane to move towards because it's on the convergent side of the high. And what do I mean by convergent? Well, what I mean is that when winds are rotating around a high pressure system in the subtropics, generally the southeastern flank here has convergent winds aloft, meaning that air is piling up, slowing down as it moves forward, causing the air to sink, which is not favorable for thunderstorm activity. And why is this the convergent side of the high? Why can't it be this side of the high that's convergent? Why is it always the southeast flank? Well, it's because of the general structure of the Earth's atmosphere. Remember, this is the subtropics in here. So when you have a high level pressure system in here, there's colder air situated to the north of it. So up in the mid latitudes, there's storms going on, cold fronts, and there's more cold air over here. That's what drives the winds because the temperature gradient drives a pressure gradient, which causes the winds on this side of the high pressure to be strong. Down here on this side of the high pressure, the winds are not going to be as strong because it's not so cool down here compared to inside the high pressure as it is up here. So when you have a big high, it's going to be a stronger temperature gradient to the north of it than to the south of it, which means that the winds on the southern side are not going to be as strong, and thus as they come around, they're moving fast up here. They come around the east side, and as they come to the south, they slow down, and as they slow down coming around the high, they pile up and they cause air to sink near the hurricane, which is the worst side of the high for them to be on. So as this comes west, Adrian's going to be feeling the effects of this, and I have a feeling this is going to limit its intensity. If we look at a close-up of the water vapor this morning, this is great for looking at the structure of hurricanes. You can see, I think there's a clear injection of dry air into the core last night. You can see the eye is getting more defined but ragged. It's getting drier. You can see that there's a break in the eye wall that forms here. Likely, if we had microwave imagery, we've still got several hours before we have a new one. There's been no new ones all night, but we'd probably see a broken eye wall if we had a new microwave image right now. The eastern side of the eye wall is very weak, as you can see by the brightness temperatures in this image, and the west side is fairly strong, but this is not that great of a core right now. This is the latest image from total precipitable water imagery, and you can see that there's an injection of dry air that you can see wrapped around the core right here. And this is also very old. This is from 5 Zulu last night, which is quite a while ago. I believe that was 8 hours ago, but you can see the dry air injection that has continued to wrap in here, and there's dry air coming up from the southeast as well. This will only get worse with time as this system moves northwest and this dry air gets pulled in with the stable air mass, which I showed you yesterday on the satellite. And this will only continue to be a problem. This is the first sunrise image that I just got to pull off here before I started the video. Notice the thunderstorms going off on the west side of the eye wall. Here's the eye. You can see it's not clear yet. There's still some clouds down here. And notice the eastern side of the eye wall, there's a break right here, which would probably show up on microwave imagery. This entire side of the eye wall is at a lower level. Notice how the convection gets stronger right in here. It's at a lower level here. And this entire eastern side of the system, I don't know how well you guys can see this on the video quality, but this entire side of the system is void of brand new convection. You can see the ruffled top. I'm not sure how to say it here. It's a bubbling top. You can kind of see the convective tops going off on this side of the system. You can see there's new convection going off. Right here, everything has been eaten away, at least for the moment. Everything is eaten away. You can see mid-level clouds. They're at an entirely lower level than down here. And you can see that on the infrared. You've got reds over here, yellows over here, indicating that the cloud tops are much lower on the eastern side of the system. And you can see that on the visible. All the convection has been eaten away right now, which is because of dry air entrainment. And I think this is going to limit Adrian. It's still a Cat 1. I think it's near a top-end Cat 1 by about this point. I have a feeling that with the eye showing up, the NHC is now going to upgrade this to a Cat 2 with the next morning advisory, but we'll see how it goes. The Dvorak estimates will probably try to put this at Cat 2 or higher. I saw an estimate this morning that had it at 115 knots, which is completely unrealistic, but Dvorak will tend to do that when it sees an eye. As soon as the eye pops out, it goes bonkers with the intensity, but we'll see what the NHC thinks. It's interesting to note that what I was saying yesterday with this trying to remain a Cat 1 and not getting to Cat 2 is starting to be reflected by some of the intensity models. Remember, the entire consensus was unanimously up in here for the next couple of days yesterday when I showed this graph. Now look at the majority showing it remaining at steady intensity below the Cat 2 threshold for the next few days and then eventually weakening as it moves over colder water. I have a feeling that the models are going to continue to catch on to this, and regardless of whether the NHC upgrades it to low-end Cat 2 based on the eye feature or not, I still think this is just an upper Cat 1 and will remain that way, and I think that dry air is going to continue to be a problem and increasingly a problem today. You can see the eastern side of the system getting eaten away already, and as this moves northwest, it's only going to become weaker as time goes on. So we will see what happens. It's an interesting exercise in forecasting here in the Eastern Pacific, where a storm is not really threatening land, and that's why these storms are so great. Alright, that's it for today. Thanks for watching.